Let us solve question 3. A. Solve x plus 1 e power x minus e power y dx equal to x times e power y dy of 2 mark. So now this is a ordinary differential equation. So let us solve this. So here we have like this x plus 1 e power x minus e power y dx, then plus, let us take this part left side, so minus x e power y dy equal to 0. So we can say like this is of the form m dx plus n dy equal to 0, where m is x plus 1 e power x minus e power y, and n is minus x e power y. So let us find delta m by delta y. So we try to see whether it is exact or not. If it is exact, then del m by del y equal to del n by del x. So del m by del y, so derivative with respect to y. So here we see it is only x term, so that derivative is 0, and minus derivative of e power y is e power y. So this is minus e power y. And let us find delta n by delta x. So derivative of this minus x e power y with respect to x. So only x term here. So that is minus derivative of x is 1 and e power y. So we can see that del m by del y equal to del n by del x. And so this differential equation 1 is exact. Now once it is exact, we can solve it easily. The solution is integration of m dx, consider y as constant, plus integration of terms of n not involving x dy equal to c. So integration m is x plus 1 e power x, so that is x plus 1 e power x minus e power y dx m dx. Now in n we have only one term, and that term contain x, so we don't have any term in n to be integrated, so 0 equal to c. So now integration of x plus 1 e power x is integration by parts. So what is that integration? X plus 1 you can keep as it is, e power x integration is e power x minus derivative of x plus 1, that is 1, and this integration that we found right here and dx, and that is equal to c. This integration is 0. So we have x plus 1 e power x minus, okay, one more thing we need to take care, yes, and integration of this e power y is also there. So minus, what is the integration of e power y? E power y is constant, so e power y, and integration is x, n equal to c. Fine. So this is x plus 1 e power x minus e power x minus x e power y equal to c. And that this e power x gets cancelled. So we have x e power x x, this e power x and e power x cancel, x e power x minus x e power y equal to c, and therefore x e power x minus e power y equal to c is the required solution. Okay, next b, solve the initial value problem y prime plus 3y equal to sin x, y at pi by 2 equal to 0.3 is of 3 marks. So let us now solve this example. So here we have like this, dy by dx plus 3y equal to sin x. So we can see that this is of the form dy by dx plus py equal to q. So this is a linear differential equation. So we need to find out the integrating factor. What is integrating factor? E to the power integration p dx. So it is e power integration p is 3, q is sin x. So that is e power 3x. What is the solution? Solution is y into integrating factor equal to integration of q into integrating factor dx plus c. So therefore y into e power 3x, q is sin x, and integrating factor e power 3x. So e power 3x sin x dx plus c. Now here we have to use one integration formula. Which one? E power ax sin bx plus c. What is that? Is equal to e power ax upon a square plus b square into a sin bx minus b cos bx. So this is y into e power 3x equal to Now here e power 3x, a is 3 and b is 1. Okay, so 3 square plus 1 square into 3 sin x minus b is 1 cosine x plus c. So we have y into e power 3x equal to e power 3x by 10, 3 sin x minus cosine x plus c. You can also write in this way, y equal to 1 by 10, 3 sin x minus cosine x plus c into e power minus 3x. Now we are given condition. So let us apply this condition. Given y at pi by 2 equal to zero point 0.3. What does it mean? It means that y equal to 0.3 when x is equal to pi by 2. This is the value of x and this is the value of y. So therefore this is 0.3. Here we have to put 1 by 10. Sin pi by 2 is 1. So this is 3. Cos pi by 2 is 0. So minus 0 and plus c e power x is pi by 2. So minus 3 pi by 2. Okay. So therefore this is 0.3. 3 by 10, so 0.3. This is 0.3. So that is cancelled. So 0 equal to c into e power minus 3 pi by 2. And therefore c equal to 0. And therefore required solution is y equal to 1 by 10, 3 sin x minus cosine x. Fine. Next. See. Solve x square y square plus 2 into y dx plus 2 minus x square y square into x dy equal to 0 by reducing to xz form. Okay. So here, just by looking to the question, we can see that this is not in xz, but by multiplying some integrating factor, we can make it into xz. Okay, we see that it will not be xz. Okay, it is easy to see. So here the equation is like x square y square plus 2 into y dx plus 2 minus x square y square into x dy equal to 0. Now this is of the form m dx plus n dy equal to 0, where m is this one and this one is n. Okay, so if I find del m by del y, now you need to take care y is inside, y multiply here. So derivative with respect to y, it will be y cube. So this is 3 times x square y square plus this is 2y, so 2. And same way del n by del x, same way x multiply here, so 2x, so derivative is 2, x multiply here, so minus, it will be x cube, so minus 3 x square y square. We can see that these are not equal. Okay, so therefore del m by del y is not equal to del n by del x, and therefore differential equation 1 is not exact. But we know that if our function, if our equation is of the form like this, some function in terms of xy into y dx plus some function in terms of xy into x dy equal to 0, then the integrating factor is 1 upon mx minus ny. And here you can see that the differential equation given in terms of xy, this form f of xy into y, this form g of xy into x dy equal to 0. So integrating factor 1 upon mx minus ny. So this is equal to 1 upon, now m multiply x, so m is this much, the whole term is m, so mx, so here you can consider that xy multiply here xy. Okay, so that is x cube y cube, then 2xy, so this is mx minus ny, so this is n, and multiply with y, so here you can consider xy, so this is 2xy, multiply xy here, so minus x cube y cube, so this is 1 upon mx minus ny. Simplify, you will get, so this 2xy cancel, this is x cube y cube, and minus minus plus x cube y cube, so this is 1 upon 2 x cube y cube. Now this is integrating factor, so multiply this integrating factor to our equation, so multiply 1 upon 2 x cube y cube to given differential equation. Okay, so we have to multiply 1 upon 2 x cube y cube, so here now x square y square plus 2 outside y, and we have to multiply 1 upon 2 x cube y cube dx, then plus 2 minus x square y square and outside x, so that is x upon 2 x cube y cube dy equal to 0. So therefore now let us simplify, So this is x square y square. This is x cube y cube. So 1 x square y square cancel. So 1 x remaining, y cancel. So this will be 1 upon 2x. Then this is plus 2 cancel, 1 y cancel. So 1 upon x cube y square dx plus x cancel, 2 cancel. So 1 upon x square y cube minus x square y square. So x square cancel, y square cancel, 1x also cancel. So x cube cancel, y square cancel. So minus 1 upon 2y dy equal to 0. This we can consider as of the form some m star dx plus some n star dy equal to 0. Now let us find del m star by del y. This is m star. So this is 0, x is there, so that it is 0. Derivative of 1 upon y square. Derivative of 1 upon y square. What is derivative of 1 upon y square? Minus 2 by y cube. It is of the form y power minus 2. And derivative of y power minus 2 is minus 2, y power minus 2 minus 1. So y power minus 3. So it is like that. So that is nothing but minus 2 upon x cube y cube. Same way del n by del x. So here this term 1 upon x square derivative is minus 2 upon x cube. So minus 2 upon x cube and y cube is already there and this term is 0. So you can see that both are same. So therefore del m star by del y equal to del n star by del x, and therefore differential equation 2 is exact. So what is the solution? Solution is integration m star dx y constant plus terms of n star not involving x dy equal to c m 1 upon 2x plus 1 upon x cube y square dx terms not involving x. So this term is having x, so only minus 1 upon 2y. So minus 1 upon 2y dy equal to c. Now integration of 1 upon x is log x. Then integration of 1 upon x cube. So integration of x power minus 3. So x power minus 3 plus 1 upon minus 3 plus 1. So this is a minus 1 upon 2 x square. So minus 1 upon 2 x square and y square is constant. So it is here. Then minus 1 upon 2 integration of 1 upon y is log y equal to c. And therefore this is 1 by 2 log of x minus log of y. You know log x minus log y is log x by y. So log of x by y minus 1 upon 2 x square y square equal to c. So that is the answer. And there is also one more question, or. So let us solve that also. So that is, solve x dy by dx equal to y square plus y. So this is a differential equation which is a Bernoulli equation. Let us see how it is. So here you have x dy by dx equal to y square plus y. Now can we write this way, like dy by dx, let us take y on this side, x also divide, so minus y by x and is equal to y square by x. Okay, so this is of the form what? Dy by dx plus py equal to q y power n. Okay, so that is Bernoulli's differential equation. So what do? We have to do like this, divide by y square, that is the first step. So therefore it is y power minus 2 dy by dx, then minus 1 upon x 1 upon y is equal to 1 upon x. Now take this as a v. So assume, so consider v equal to minus 1 by y. Even you can take 1 by y, also no problem. If you take 1 by y, then also not a problem. dv by dx equal to, what is the derivative of 1 upon y? Minus 1 upon y square. So that is 1 upon y square dy by dx. So y power minus 2 dy by dx is dv by dx. So let us put it here. So from 1, y power minus 2 dy by dx is dv by dx plus, because we have considered this minus sign. 1 upon y is minus 1 upon y is v. So this is v by x and is equal to 1 by x. So now you can see that this is nothing but linear differential equation. So Bernoulli differential equation is nothing but convert to linear differential equation. It is dv by dx like this, dv by dx plus pv equal to q kind. So what is integrating factor? E power integration p dx. So it is e power integration 1 upon x, and so it is e power log x, and so that is nothing but x. What is solution? Need to take care here. Here not y, but it is v. So v into integrating factor integration q into integrating factor dx plus c. So v into integrating factor x What is q? Q is 1 upon x. So integrating factor x into 1 upon x dx plus c. But take the value of v. What is v? Minus 1 upon y. So this is minus 1 upon y into x. X cancel, integration of only 1. And so that integration is x plus c. So this is the answer. Or you can say like this, minus 1 upon y equal to 1 plus c by x. So that is the solution. Thank you.